Let's look at the TCP IP model, the foundation of networking. Now that you understand the basic components of a network, we're going to discover how computers actually communicate. Firstly, some terms. TCP stands for Transmission Control Protocol, and IP stands for Internet Protocol. You'll be familiar with IP as in IP address, and we'll cover TCP in detail in the next lesson. It seems like computers have always been able to communicate with one another. However, before the 1960s, computers could only process data, make calculations, and output results. They couldn't share that data with a computer across the country. Friends couldn't communicate via email. There was no way to play online games, stream content, or learn or work remotely. They couldn't just connect computers together and expect them to communicate. A model for computer-to-computer communication had to be developed, and a network along with it. In the 1960s, the first ever network was created, ARPANET. It was developed by the US Department of Defense and could share resources and information securely across the country. You can see just how complicated the network diagram is. Out of interest, in the bottom right, you can see the Pentagon, the National Security Agency, and New York University. What started as an internal US government project then became what we now know as the Internet. By 1982, ARPANET had fully adopted the model that we now refer to as the TCP IP model, and it's been the foundation of networking ever since. Let's see how it works. The TCP IP model has 5 layers: application, transport, network, data link, and physical. Data created by an application is packaged up as it's passed down through each layer. It arrives at the physical layer fully packaged and is then sent to the receiving computer. The application layer is where the data is created. Application layer protocols operate at this layer, such as HTTP, which is web browsing, FTP or file transfer, or SMTP, email, for example. The transport layer is where the method for transport is decided, either TCP or UDP. We'll cover both of these later. It's also where port numbers are added, a vital addition that we'll cover in Lesson 4. The network layer is where the source and destination IP addresses are added, telling the traffic where it came from and where it's going. The data link layer is where the hardware or MAC addresses are added so that the data can be routed in the internal network. The physical layer is where the physical zeros and ones are sent. The cables and network interface card, or NIC, operate at this layer. Now we're familiar with the layers, let's look at how data is actually sent from one computer to another using this model. First, the sending computer encapsulates the data. This is the term for packaging up the application data as it passes down through each layer. Starting at the application layer, data is produced by an application. This could be your email application ready to send an email to your friend. The data is then passed at the transport layer, where TCP or UDP headers are added. These headers determine the method of transport, TCP or UDP. They contain the source and destination port, as well as some reliability checks. This is then passed to the network layer, where IP headers are added, including the source and destination IP address. Ethernet headers and footers are added at the data link layer. This is where the source and destination MAC addresses are added. More of this to come later. Finally, this is passed to the physical layer, where the fully encapsulated data is sent from the network interface card and to the receiving computer. When the traffic arrives at the physical layer of the receiving computer, it begins decapsulating the traffic, unwrapping it as it's passed up through the 5 layers of the TCP IP model to be finally received by the application. In this case, your friend's email application. It's then passed up to the data link layer, where the Ethernet header and footer are read, making sure that the incoming traffic is destined for the computer's hardware address. Once read, the header and footer are removed or stripped. It's then passed up to the network layer, where the IP header is checked to see that the traffic is destined for the computer's IP address. The IP header is then stripped. It's then passed up to the transport layer, where the method of transport is unwrapped and the source and destination ports are checked to determine which application to send the traffic to. The TCP or UDP header is then removed. Finally, we're only left with the data. This is passed up to the application layer, where it's read by the receiving application. In our case, the email appears in your friend's inbox. The data has now been sent and received, and the whole process of encapsulation and decapsulation are complete. As the data is encapsulated, it's referred to as different things at different layers. At the transport layer, it's called a segment. At the network layer, it's called a packet. And at the data link layer, it's called a frame. The 5 layers of the TCP IP model will form the chapters of this networking volume. We'll descend through each layer at a time, exploring in detail all the things you need to know as a cyber professional. When analysing network traffic, it's vital to understand this model. Your ability to dissect information at each layer will mean the difference between you spotting a cyber attack and missing one. Attacks can happen at different layers. ARP poisoning and man-in-the-middle attacks occur at the data link layer, IP spoofing and sinkholing at the network layer, and malware beacons or ransomware at the application layer.